Problem 2, part B. What's the difference? It looks like the same problem. This piece of cheese of given mass m is sitting on rotating platform distance b from the center. Okay? The coefficient of friction between this piece of cheese and the platform is mu. The difference is that they do not give us omega naught. Omega naught is not given. What they ask us to find is what is the largest value of omega. So we are looking for omega this time. What is the largest value of omega? Omega maximum. That's what we are looking for. Omega maximum. What is the largest omega that I can have before this piece of cheese starts slipping? So we are looking for omega. We know that this piece of cheese still does not slip, but we are looking for this critical value. What is the largest omega right before it starts slipping? So is force of friction mu n or it's not mu n in this case? Well, it's the maximum value. It's maximum value of force of friction, which is mu static. It's still static, it is not moving, but it reaches its maximum value critical situation when it is maximum omega that we can afford right before it starts slipping. So the magnitude of force of friction is equal to mu static times normal force. We already know the normal force. We found it in part A. I will be just using it. Normal force is mg, so the magnitude of the force of friction is mu mg. This is the magnitude. Okay, I'm looking for omega maximum. Which law will I use? Let's look at the second law. Can I use my Newton's second law to find omega? Look, I know something about the force, and omega is right here. I just need to figure out, does the force of friction still have only radial component as it was in part A? Let's check. F sub r is d2r dt squared is 0, again, because r is constant, so I have fr minus mr omega squared. It's still same as in part A, minus m, r is b, and omega squared, omega is unknown now. What about f theta? F theta is m dr dt, 0, r is constant, and alpha is 0 because omega is constant. It's omega maximum, it's constant omega. No f theta. We still just have force of friction in radial direction only, and the projection of force of friction with our choice of coordinate system with IR out is negative, which means that the force of friction is towards the center. It is towards the center. Force of friction acting on this piece of cheese is towards the center. Okay, now this is projection of force of friction, and I will rewrite this equation because I know what is the magnitude of force of friction. It is mu mg. So I have projection F sub r is negative, which gives me minus mu mg. This is F sub r, and this is equal to minus mb omega maximum squared, since I put here force of friction as its maximum value, static maximum value of static friction mu n. Are we ready to solve for omega maximum? Yes. Minus minus plus, m is gone. What is omega maximum? Maximum angular velocity that I can afford right before this piece of cheese will start slipping. It is mu times g divided by b, and then it is square root. Is dimension right? Let's check the dimension real quick. Mu is dimensionless. What is dimension for g, acceleration of gravity? It is meters per second squared. What is b? b is in meters. Meters, square root of 1/second squared will give me 1/second, which is the dimension for mega. So we solve for mega maximum angular velocity that we can have right before this piece of cheese will start slipping. Problem solved.